Dante AV latency considerations. Video processing takes time and it's different for each codec. Each parameter will affect the processing time and therefore the overall transport time. The network must be configured to allow enough bandwidth for Dante AV and should be optimized for the media packets and PTP. The time between frames on video is measured in milliseconds, while we measure the audio samples in microseconds. That means that it will take more time for a video packet to be created than an audio packet. In a system connected with Dante, the sound will take some time to arrive at the destination. The sound of a musician will go through the device until it reaches the Dante card inside that device. The Dante cards will then packetize the uncompressed digital audio and send it through the network. Finally, the other Dante card will depacketize the audio data and send it to the host device to be output through the headphones to the other musician. Each musician is hearing the other one after 1 millisecond latency, and so the bass sound will be captured and will return through the network. If the bass mic picks up a little bit of the sound of the drums leaking from the headphones, that sound would be 2 milliseconds after the original hit on the drums. There are Dante devices that can perform lower latencies, for example the Brooklyn cards, very commonly used in mixing desks. If we consider the latency of a wireless in-ear system, the impact of such low latencies is minimum on the overall round-trip latency. Dante devices default to 1 millisecond audio latency. Considering approximately 100 microseconds for the packets to go through each switch, this configuration would suffice for up to 10 switches in a mid to large network infrastructure. In Dante AV devices, the audio will follow these latency adjustments. A Dante AV Ultra module can perform audio latencies down to 250 microseconds as well. However, only the audio packets will follow these settings. Dante AV-H can do down to 1 millisecond audio latency, and it would behave as any other Dante embedded platform-based solution that work with existing processor inside other devices. Dante will packetize the audio data and send them as soon as they arrive. As the Dante audio packets are time-stamped, receivers will be able to buffer audio data and start playing out exactly after the latency agreed. We recommend reviewing the Dante certification program on the chapter about clocking in a Layer 2 environment for more details about PTP, Precision Time Protocol, and the clock leader election. An encoder will take some time to process the information of each frame. In this image, we have 12 frames per second, each takes 84 milliseconds of time. We all agree that 12 frames are too few for our eyes to be tricked. So, professional cameras will work with up to 60 frames per second, which means each frame takes 16.7 milliseconds approximately. That gives enough material to produce a smooth motion. At 24 frames per second, the cinema standard frame rate, each frame will take 41.7 milliseconds. When talking about latency in Dante AV, we must consider the processing time and the network transport time. The image that comes on the physical input will need some time to build the entire frame. The encoder will take some time to compress and send the encoded video data to the Dante step of the process. The media will then flow from the Dante Video TX on the encoding device to the Dante Video RX on the decoding device. Once arrived, the encoded video packets will be delivered to the video decoder that will then be able to build all frames back again in order to reproduce them. Each codec will have different parameters, but latency is typically measured glass to glass, from the video input on the encoder to the video output on decoder. A camera will work very similarly, adding the light-to-digital conversion step done by the sensor. To reduce the bandwidth consumption, Audinate supports multiple video codecs. JPEG 2000 is an intra-frame codec, that means it encodes each frame fully. JPEG 2000 will provide a visually lossless data reduction to the stream, allowing these resolutions to traverse the 1 gigabit per second network pipe. JPEG 2000 is also lower latency because it can encode and send that image right away. Multiple teams working together and interacting with the subject on camera, as in live events or a broadcast studio, will definitely want to work with the lowest latency possible in order to synchronize their actions with the real thing. MPEG is an inter-frame codec. It does its best work when multiple frames are encoded as a group. The first in the group is called iframe or keyframe, where it describes the full image. Subsequent frames will only describe changes and are called delta frames. JPEG 2000 will also be more resilient to errors in transmission. Because JPEG 2000 encodes each frame fully, any errors will be contained to one part of one frame. By contrast, MPEG will generally garble the image and possibly compound it until the next keyframe arrives. Corporate and installed AV systems that will use a feed of the video to be sent across the building for recording or even being streamed on the internet, they could afford to have a modest latency between the transmitter and receiver once the receiver side doesn't need to respond so precisely timed with the action being caught on camera. On Dante AV Ultra devices, it's possible to control the behavior of the codec inside the Dante AV device. Go to Device View, Video Config, and check the compression profile applied to each encoder. Users can switch between ultra-low latency and broadcast modes. In ultra-low latency or ULL mode, the encoder splits the frame in 16 parts and encodes each tile individually. Once the encoding is done, it can send each tile in a different package with positioning metadata. In broadcast mode, the encoder will encode the entire frame at once. Therefore, it needs to wait the whole frame duration. If instead of waiting for the whole frame, the encoder can start compressing smaller tiles of the image, the whole process can be faster and save up valuable time for low latency applications. With Dante AV Ultra devices in ultra-low latency mode, a packet can be delivered to the decoder after only 8 milliseconds. Considering that at 60 frames per second, each frame has approximately 16.7 milliseconds, with a latency of only 8 milliseconds, a Dante AV Ultra device can deliver packets with less than half a frame of latency. If a whole frame takes 16.7 milliseconds and in ultra-low latency mode the frame will be split in 16 tiles, it is the same as if we account for 1 millisecond for each tile in each step of the process. From the uncompressed video to the encoder, from the video encoder to Dante AV Ultra, another 1 millisecond transport time across the network, and right up to the Dante AV Ultra receiver that will send the encoded video to the decoder, and finally, the whole image will be built to be played out through the physical SDI or HDMI port. When measuring latencies, we need to consider the little time that a screen takes to display the image coming from their HDMI or SDI input. As long as both screens are the same or have the same input lag, we can compare the playout time between the transmitter and the receiver. In this example, the media player is sending its image to a Dante AV encoder, and we can monitor the image through the local monitor out that is available on the unit. After sending the image across the Dante network, the decoder is displaying the same image 8 milliseconds later. Let's have a look at a latency demonstration using Dante AV Ultra encoders and decoders. We have captured the same demonstrations with the 25 frames per second camera and the 240 frames per second camera in order to highlight the video latency glass to glass. Frame of frame, you can see that transmitter and receiver are half a frame apart. As soon as the transmitter has the entire next frame information, the receiver is already displaying the upper half of that frame. In broadcast mode, each step of the process will need to wait for the entire frame, resulting in latencies that are proportional to 4 frames. Still very low latency if you consider the amount of data that needs to be sent across the network. In case of multicasting with Dante AV Ultra, all receivers will be able to receive and play out the image at the same time in perfect sync. Now let's freeze the image and compare displays. As you can see, both receivers are in sync, displaying the same information. Latency in video is calculated in frames, but it all depends on the application of what kind of camera you're using, so don't take the absolute number as the only truth. With Dante AV-H cameras, the latency will vary according to its codec parameters. Typical latency for H.264 cameras is between 80 and 120 milliseconds, around 4 to 5 frames. Users can adjust the iframe interval to reduce latency. The bigger the interval, the longer the latency. Check your Dante AV-H device settings to improve the latency performance. H.265 is usually half the bandwidth of H.264, but they both behave in the same way in terms of latency. Adjust the frame rate to match the final output. Bitrate type, constant or variable, are specifications that can help controlling bandwidth. Constant bitrate is better for time-sensitive streams where a traffic peak could put the network at risk, and variable bitrate tends to produce higher quality results as it allows more data to be used when needed. Adjust the iframe interval, keeping in mind that the more frames you want to group, the more time you will need to wait. As H.264 and H.265 are interframe codecs, the interval is directly proportional with the overall latency. We could use that same example to measure latency in a Dante AV-H subscription. Taking we have 2 frames iframe interval, we will need to wait approximately 16 milliseconds times the iframe interval on the encoder and decoder to rebuild that image in that time interval. Now let's demonstrate Dante AV-H latency with the same setup as before. Here you can see that the ball is dropped on frame 1, it hits the others on frame 2, and then it will take 1, 2, 3 more frames for both Dante AV-H decoder and Dante Studio to display that ball hit. Alright, summarizing Dante AV latency. Each codec will have different latency performance according to the settings, so please check with the device's manufacturer what settings are supported. On Dante AV Ultra, compression modes can help the overall latency. In ultra-low latency mode, the packets can be sent faster than in broadcast mode. Latency is measured glass to glass, however, each application will have their own requirements for video delivery. Within the Dante AV family, you have Dante AV Ultra for low latency requirements and Dante AV-H for modest latency demands. Whether you're looking to send camera-generated images or computer-generated graphics such as a PowerPoint or a spreadsheet, Dante AV delivers the image quality you need for the future on the network infrastructure you have today.